we can talk a little bit about the rate at which the depth changes. We've appended some columns onto the table of depths and times, clock times that we used before. And we label these, okay, this is labeled delta t. That little triangle in front of the t is a Greek capital delta. It stands for change in clock time. This is a delta y, change in y. And delta y is going to be measured in centimeters since y is measured in centimeters, delta t in seconds since t is measured in seconds. And over here we're doing the ratio delta y divided by delta t, and that's going to be in centimeters per second since y is in centimeters and t is in seconds. Between clock time t equals 0 and t equals 11, there's an 11-second interval. Between 11 and 24 it's a 13-second interval. Then 24 to 36 is a 12-second interval, and so on. Each depth interval is the same. We go from 90 to 80, that's a depth interval of negative 10. 80 to 70, negative 10. Every depth interval is negative 10. Now if we divide the negative 10 centimeters by the 11 seconds, we see that there are, well, if we went 10 centimeters in 11 seconds, we'd be going a little less than 1 centimeter every second. So negative 10 centimeters divided by 11 seconds gives us actually negative 0.91 centimeters per second. And then if we divide the negative 10 centimeters by the 13 seconds on the second interval, we get negative 0.78 centimeters per second. We'll note that the quantities that we get on this first interval come from both the first and the second data point. So we've kind of written those quantities in the margin, or lined up with the margin in between the two data points, to indicate that all these quantities come from one data point as much as from the other. And that's of course true all the way down the table.